Hi guys, we got lesson 2-5, literal equations and formulas, and this seems to be one of the toughest lessons for people, so don't get too frustrated if you don't understand anything in the video. It's going to be pretty short because there's only a couple questions, but we will definitely practice a bunch of these in class tomorrow, so don't feel overwhelmed if you don't quite understand everything just by watching the video. Okay, so the vocabulary here is a literal equation. It's just an equation that involves two or more variables. We've mostly been doing equations like 6x equals 11 or something like 3y plus 5 equals 7. And we've only been working with one variable. Well, a literal equation has two or more, so it could have like 3, 4, or 5. So I just threw some examples. I just made this one up. Like 3x plus 5y. So you have two variables, x and y. That would be a literal equation. And then our formulas that we're used to, like area equals length times width, that one has 3. And that's like if area equals length times width for a rectangle. Area of a square would be area equals pi r squared. So you have two variables, area and radius. So that's all literal equations are. They just involve just more than one variable, at least two, but it could be more than two. Okay, so problem 1, it goes with the got it, which we kind of skipped, but you can see you're ordering pizza and sandwiches. You have a budget of $80. So that's why this equation is equal to $80. Now, pizzas cost $10. That's why you have 10x. And I'm just getting this right from the book on page 109. And sandwiches cost $5. That's why you have the 5y. So they said x represents the number of pizzas, y represents the number of sandwiches. I mean, that doing the got it problem isn't that big of a deal, but it says the question part is how many sandwiches can you buy if you buy 3 pizzas? So if you know that you're getting 3 pizzas, you want to substitute the 3 into the equation. So let me rewrite the equation. 10x plus 5y equals 80. Now, I'm just going to take the same equation, but I'm going to use S and P for sandwiches and pizzas because to me it just is a lot easier. So if X represents pizzas, I'm going to make this 10P plus, and then Y represents sandwiches, 5S equals 80. Okay, so how many sandwiches? So that's the part you don't know. So you're going to solve this equation for S. And that's going to tell you how many sandwiches can you buy if you buy 3 pizzas, if you buy 6 pizzas. Well, what you could do is, if you know you're buying 3 pizzas, so this is option number 1, you could plug in 3 for pizza. So 10 times 3 plus 5s equals 80. And then this would be 30 plus 5s equals 80. Subtract 30 from both sides. So you have 5s equals 50. Divide both sides by 5 and you get s equals 10. So you could buy 10 sandwiches. Now what we're actually going to do here is, instead of doing it like that, because now it says how many sandwiches can you buy if you have 6 pizzas. So what they really want you to do is solve this equation for the variable s. So if we have 10p plus 5s equals 80, and we solve it for this variable, then no matter what number we want to plug in, we can just plug into the equation. So to solve for s, if you think of that thing, box it and bridge it, box and bridge or something like that, whatever Mr. Kirker told you guys. If we box around the variable, we want to keep that. Okay, everything else needs to get to the other side. So I need to subtract 10p from both sides. Now 10p minus 10p is going to cancel out. I'm going to have 5s equals, now I have 80 minus 10p. Then to solve this for s, I have to divide this by 5. So I have to divide this by 5, and I have to divide this by 5. So I have s equals 80 divided by 5 equals 16 minus, now 10 divided by 5 would be 2, and then we still have the p. So now, if I wanted to figure out how many sandwiches I could buy if I had 3 pizzas, it's a lot easier to do 16 minus 2 times 3, and 16 minus 2 times 3 would be 10. And then if I wanted to do 6 pizzas, I could just plug in 6 for p. So the first way, over here, we just plugged in the 3, and we went through and we solved the equation. But what you want to practice is solving these equations for s, and then you can just plug in p. Okay, so I know that was a lot of steps, but you'll get the hang of it the more we practice it. Okay, so got it, number 1. We want to solve this equation. 4 equals 2m minus 5. And we want to solve it for m. 5n. Sorry, I didn't think something was right there. We want to solve it for m. And then we want to plug in, and we want to figure out the values of m when we plug in these 3 numbers. So first, let's solve it for m. So I would say box around the m, the 2m, because that's not going anywhere. So what we need to move to the other side so that we just have m is this minus 5n. So if I add 5n to both sides, these will cancel out. And over here I have 5n plus 4, or 4 plus 5n, it doesn't matter which order you write it, equals 2m. Then in order to solve for m, I need to divide this by 2. So I have to divide this by 2, and I have to divide this by 2. Okay, so I have 5 over 2n plus 4 divided by 2 would be 2 equals m. So that's my equation solved for m. Now, what's the value when n equals negative 2? So when n equals negative 2, I have 5 over 2, and I'm going to plug in negative 2 plus 2. And that's going to tell me what my value for m is. So see here, this 2 and this 2, they're going to cancel out because I have 1 on the denominator, then I'm multiplying. So that's going to turn out to equal negative 1. So I have 5 times negative 1, which is negative 5 plus 2, and that's equal to negative 3. Okay, so this is good. This one probably won't be one of the got it questions for tomorrow because there's just too much like what you actually want to put in. But when the value is negative 2 for n, the m value is negative 3. Okay, let's see. When the value is 0, so when n equals 0, let's plug that into the equation. So we have 5 over 2 times 0 plus 2. Well, anything times 0 is just 0, so that's equal to 2. So when the n value is 0, the m value is 2. And we could do the same thing. We could plug in 2, but plugging the number in isn't as difficult as actually solving the equation. So I won't ask you to try and put this one in the form tomorrow because it's too difficult for this one. Okay, now problem 2 is rewriting a literal equation with only variables. So we have the equation ax minus bx equals c, and there's not a single number there. And for some reason this is the toughest part for people, but the more you practice these, the better you get at them. So we're trying to solve this for x. Okay, well, if we do the boxing thing, we have x's here and we have x's here. So there's really nothing to move. So what you need to do is you need to backwards distribute. It's called factoring. So let me rewrite this over here. ax minus bx equals c. If both of your terms have an x in it, you want to pull the x out front. Now think backwards distributing. X times what got you to ax? Well, if I put an a here, and you think, like, if I would distribute x times a, I would get back to ax. And then, from the next piece, if I pulled out an x, all I had left with was the b. So all I have left with, and then on the other side, I just have c. Now, in order to solve this for x, if this was x times 5 equals c, and we wanted to solve it for x, we would divide both sides by 5. So the 5's cancel out. Well, if this is x times a minus b in parentheses, we want to divide both sides by a minus b in parentheses. to cancel them out. So I know the equations are going to look crazy, but it's going to be x equals c over a minus b. And you can put that in parentheses, or you don't have to put that in parentheses. Okay? Like, rewind that and watch that again if you need to, because that's tough. But we do have another problem like this in the video. Okay, so this one, they want us to solve this one for x. So we have negative t equals r plus px. Now, if we're solving for x, this time we only have x in one spot. So it would be a good idea to box that. Now, we need to get rid of the r. So if this was negative t equals 5 plus x, we would subtract 5 from both sides. So right now we need to subtract r from both sides. Now, t and r aren't like terms. It's not like you're taking 10 minus 2. So you just leave it as negative t minus r. That's all you can simplify there. And that's equal to px. Now to solve for x, you got to divide this by p. So you have to divide this side by p. So your equation is negative t minus r divided by p equals x. And I know they're crazy because there's no numbers there, but it's just practicing solving literal equations. Okay, extra problems. I just threw these in there. We might actually do these in class tomorrow too, but just so you can get a little bit more practice so you're not totally confused when you come in tomorrow. Both of them need solved for x. So we have ax minus x equals c. Now this is one of those ones where you have x in both of your terms. So you need to pull the x out of both of them. So write the x and then write a parentheses because you're backwards distributing. So out of the first term, if I pull out an x, I'm left with a. Out of the second term, if I pull out an x, I'm left with nothing. But you can't be left with nothing because this was really 1 times x. So what I'm left with is negative 1. And then it's equal to c. And then you divide both sides by a minus 1. And your equation is x equals c over a minus 1. Okay, and number 2, we're going to solve this one for x. So here's our x. At least we only have one of them. So in order to start solving this for x, first thing I want to do is get rid of the fraction. So I'm going to multiply both sides by b. And that will at least get rid of the denominator. So on the left side, I have b times y equals, and then on the right side, I just have x minus v. Now, if it was x minus 5, you would add 5 to both sides. Since it's x minus v, we're going to add v to both sides. So our equation is going to be x equals by plus v. And this is probably the got it question, I guess I'll ask you. So make sure, box this, I don't know, star this, because this is the only one that's like normal that you can actually put into a form. So I'm just going to call it extra problems number 2. And this will probably be one of the only things you couldn't put in. So just put in x equals by plus v. Okay, we might have an easier one later on, but for now, that's the only thing we're going to be able to put in. Okay, and then just a little bit more vocabulary. I know you know what formulas are. It's just an equation that states a relationship among quantities. If you look on page 110, you kind of have all your formulas. The perimeter of a rectangle is p equals 2 times the length plus 2 times the width, or just add up all the sides. Circumference of a circle is c equals pi r, circumference, that's area. Circumference is 2 pi r. Area of a rectangle is length times width. So these are formulas, but do you see how these are all literal equations? Because you have p for perimeter, L for length, W for width. You have C for circumference, R for radius, A for area, L for length, W for width. So that's why they're in this chapter, because they're all literal equations. Hopefully you know most of these. If not, I would give the formula to you on the test if you needed it. Okay, so rewriting a geometric formula it says, what's the radius of a circle with a circumference of 64 feet? Round to the nearest tenth. So if it's asking a question about circumference, you need the circumference formula. So circumference equals 2 pi r. And if it wants to know what's the radius, now what they do is they go through and they solve for the radius. So to solve for the radius, you have to divide both sides by 2 pi to cancel out the 2 pi's. Okay, so we have this equation, circumference equals 2 pi, circumference divided by 2 pi equals the radius. So now if it says what is the radius of a circle with a circumference of 64, we can just do 64 divided by 2 pi, and that's going to equal the radius. And when you put that in your calculator, you get about 10.2 feet. 10.2 feet is the radius. Now, you could have just plugged in, you could have just done 64 equals 2 pi times r and divided by 2 and then divided by 2 pi. So it's the same exact thing, but sometimes they just ask you to rewrite the equation. Okay, and got it, number 3. So what is the height of a triangle that has an area of 24 inches squared and a base with a length of 8 inches? So the formula for area of a triangle is A equals 1/2 base times height. So if it says what is the height, what they're probably going to do is have you solve this for h. So if we're going to solve this for h, let's see. Let's go through these different parts. Now, if we're going to solve it for h, we definitely need to divide by b, right, to cancel out the b. So we have a over b equals, and we still have 1/2 h. Now to get rid of the 1/2, we need to multiply both sides by 2. So we have 2a over b equals h. So we've solved our equation for h. So what is the height of a triangle? And now we can just plug in numbers. That has an area of 24. So if I do this, I guess I could shrink this down. If I do 2 times the area, which is 24, and it has a base with a length of 8, divided by 8, because that's our base, that's going to equal what our height is. So I would do 2 divided by 8. I would cancel that out just to make the multiplication a little bit easier. So this 2 divided by 2 would be 1. 8 divided by 2 would be 4. So all you're really doing is 24 divided by 4, which is 6. So the height equals 6 inches. Did you have to go through and solve this equation for h to come up with the answer? Probably not. I mean, you could have just plugged in the area and the base and the height, but this whole chapter is just about practicing solving it for one variable. But this will probably be your other got it question, because this is actually something you could put in the computer. So this would be got it number 3. Just put in h equals 6 inches. Okay, and that's it.